Hi friends, welcome to physics class. Today we are going to discuss about some important numericals. Now, our first numerical. A flywheel of mass 25 kg has a radius of 0.2 meters. It is making 240 RPM. RPM means rotation per minute. That means nothing but frequency. What is the torque necessary to bring it to rest in 20 seconds? If the torque is due to a force applied tangentially on the rim of the flywheel, what is the magnitude of the force? This is the question. Now, given what the examiner given? Mass. What is the mass? 25 kg. And radius R is equal to 0.2 meters, and frequency V0, initial frequency, is equal to 240 RPM. That gives 240 by 60 RPS. That means rotation per second. Therefore, frequency is equal to 4 RPS. Therefore, omega naught is equal to 2 pi nu. That gives 2 pi into 4 into 8 pi radian, that is equal to 8 pi radian per second. Once again, therefore omega naught is equal to how much we got? 8 pi radian per second. Now, what is final angular velocity? The final angular velocity omega is equal to 0. Now, what is the time? The time is equal to 20 seconds. So, these are the physical quantities given by examiner to us. Now, we are going for a solution. Now, solution. What is the solution? Omega is equal to omega naught plus alpha t. Therefore, 0 is equal to 8 pi a plus alpha into 20. Therefore, alpha is equal to minus 8 pi whole by 20. That it gives minus 2 pi by 5 radian per second square. Therefore, moment of inertia of the flywheel about its own axis is given by therefore I is equal to 1 by 2 mr square, that is equal to 1 by 2. What is m? 25 into 0.2 whole square. I is equal 1/2 kg meter square. Therefore, the momentum of inertia I is equal 1/2 kg meter square. Now torque acting on the flywheel. That is torque tau is equal I into alpha. That gives minus 1/2 into 2/5 pi. That gives minus pi/5 Newton meter. Therefore, torque tau is equal minus pi/5 Newton meter. Here, negative sign indicate negative sign indicate that the torque is of retarding nature. Now, torque is equal force into perpendicular distance. Therefore, torque tau is equal force cross R. Therefore, force is equal torque by R. Therefore, the force F is equal pi by 5 into 1 pi 0.2. Here we took only magnitude. Therefore, the force F is equal pi newtons, or the force F is equal 3.14 newtons. Now see, we are going to discuss about numerical number 2. An automobile moves on a road with a speed of 54 km per hour. The radius of its wheel is 0.35 meters. What is the average negative torque transmitted by its brakes to a wheel if the vehicle is brought to rest in 15 seconds? This is the question. At first, write given. What the examiner given to us? The examiner given initial velocity u is equal 54 kilometer per hour. Convert into meter per second. 54 into 5 by 80. That gives 15 meter per second. Therefore, u is equal 15 meter per second. Therefore, initial velocity u is equal to 15 meter per second. Now, radius r is equal to 0.35 meters. Time t is equal to 15 seconds. I is equal to 3 kg meter square. Now, omega naught is equal to u by r. That gives 15 by 0.35 radian per second to the power of -1, and the final angular frequency is equal to 0. Now, average angular acceleration solution. Average angular acceleration alpha is equal to omega minus omega naught whole by t. That gives 0 minus 15 by 0.35 whole by, what is small t? Small t is equal to 15 seconds. Therefore, alpha is equal to minus 1 by 0.35 radian per second square. Now, average torque transmitted by the brakes. Therefore, torque tau is equal to I into alpha. That gives minus 3 into 1 by 0.35. Therefore, torque tau is equal to minus 8.57 kg meter square second to the power of -2. So the required average torque tau is equal to minus 8.57 kg meter square second to the power of -2, or the torque is equal to minus 8.7 Newton meter, or the torque is equal to minus 8.7 joules. So this is the required average torque transmitted by the brakes to the wheel. Now we are going to discuss numerical number 3. A cord is wound around the circumference of a wheel of diameter 0.3 meters. The axis of the wheel is horizontal. A mass of 0.5 kg is attached at the end of the cord, and it is allowed to fall from rest. If the weight falls 1.5 meters in 4 seconds. What is the angular acceleration of the wheel? Also, find out the moment of inertia of the wheel. This is about the question. Now see, given what the examiner given, radius of the wheel. R is equal 0.3 by 2. R is equal 0.15 meters. Now M is equal, M means for the attached mass. For the attached mass. M is equal 0.5 kg. U is equal 0. S is equal 1.5 meters. Now T is equal 4 seconds. Let small a be the acceleration of the attached mass. Therefore, S is equal ut plus 1 by 2 at square. That is, what is S? 1.5 is equal 0 into 4 plus 1 by 2 into a into 4 whole square. Therefore, a is equal 1.5 by 8. A is equal 3 by 16 meter second to the power of minus 2. If alpha is the angular acceleration of the wheel, therefore linear acceleration is equal radius into angular acceleration. Therefore, angular acceleration is equal linear acceleration by radius. Once again, angular linear acceleration is equal radius into angular acceleration. Therefore, angular acceleration is equal to linear acceleration by radius. That gives 3 by 16 into 0.15. Therefore, alpha is equal to 1.25 into radian by second square. Therefore, torque applied by the attached mass tau is equal to radius into force. That means torque tau is equal to radius into what is force? MA. That is F is equal to MA from Newton's second law. Therefore, torque tau is equal to 0.5 into 9.8 into 0.15. Torque tau is equal to 0.735 Newton meter. Now, we know that torque tau is equal to I into alpha. Therefore, I is equal to torque tau by alpha. That gives 0.5 into 9.8 into 0.15 whole by 1.25. Therefore, I is equal to 0.588 kg meter square. The required momentum of inertia of the body is 0.588 kg meter square. My dear students, I hope you understood this video. Thank you very much for watching this video.